Hi class, this is course 3, lesson 30 on repeating decimals. Okay, so we're going to list the objectives. You do not need to write this. Do not write. But the objectives are, number 1, we're going to write repeating decimals with a bar over the repetend. And so by default we'll define repetend. Number 2, compare and order decimal numbers. And number 3, write fractions as decimal numbers with repeating decimals. So those are the things that you should be able to do at the end of this video. So writing repeating decimals with a bar over the repetend. So repetend means repeating end. Okay, so where the decimal repeats, that's where we're going to put the bar. So for examples here, we need to look at the decimal numbers and decide which part repeats. Okay, so I have an 09, an 09, and an 09. So the 09, both of those digits repeat. So if I were to write this, it would be 0 decimal 09, and the repetend bar goes over the 0 and the 9. And you need to make sure that you are very precise with that so that I can tell which digit or digits that you want the repetend bar over. The example on the right, notice that you have an 8 that repeats. Okay, so you would write this as 0.38, and which part repeats? It's only the 8, so the repetend bar goes over the 8. Okay, 2 more examples. This is a repeating 3, okay, just the 3 that repeats. So you're going to write that as decimal point 3 with the repetend bar. Now, this problem here, as well as the problem on the right, a lot of times you students will write the first 3 and then they'll say, oh, the second 3 repeats. Don't do that. If the second 3 repeats, the first one does too. Okay, so make sure that you only put as many digits as are necessary. This problem here is a little different because there is a whole number, but again, notice that you have a 1 that repeats, so you have to write the whole number part, the decimal, then the 1, and the 1 gets a repetend bar because it repeats. If you want to write fractions as decimal numbers with repeating decimals, for instance, the fraction 1/6, you divide it. So 6 will go into 1 how many times? All right. So we're going to put the decimal up, and 6 will go into 10 one time. Subtract, we get 40. 6 will go in there 6 times. 36. 4, looks like I need another 0. 40. Okay, so notice that we're going to repeat here. We had 40 there, we have 40 here. So the 6 is going to go up there and it repeats. So we'd write 0 point. Which digit repeats? It's not the 1, but the 6 does, and that's the number that gets the repetend bar. Okay, rounding repeating decimals can be a little tricky. The steps that you need to take are to remove the repetend bar, write the repeating digits, and round to the correct place. So I have 2 examples here for you. If we want to round to 5 decimal places, that means we want 5 digits behind the decimal. Oops, I need a B there, behind the decimal. Okay, so we need to remove the repetend bar first, 0.289. Write that with no repetend bar. Then write repeating digits. So the 289 repeats, and I'll just write another 289 to make sure I have enough decimal places. So then, take a look. We need 5 decimal places, so I need 1, 2, 3, 4, 5. So this is the digit here that's going to change based on this digit. Okay, so is this 8 going to stay an 8, or will it become a 9? Well, this is a 9, so that'll bump up the 8, and then my answer will be 0 decimal point 28929. Do I have 5 digits behind the decimal? Yes, I do. then you're done. Okay, let's try it again. We have a 4.3, and notice the repetend bar is only over the 521. So write out what you see, 4.3521, and then write the repeating digits. So it's not the 3, it's just the 5, the 2, the 1. And I think I have enough digits there. So I need 5 decimal places, remember. 1, 2, 3, 4, 5. So the 5, will that stay a 5 or bump up because of the 2? 2 is less than 5, so it will stay, our number will stay a 5. So this will become 4.35215. Now this will work the same. I know I gave you 2 examples with 3 digits that repeat. Doesn't matter how many repeat, the process is the same. Doesn't matter which decimal place you need to round to. If I said round them to the nearest tenth, that'd be 1 decimal place. So you're going to practice with your place value during this lesson as well. Comparing repeating decimals works a lot, works very similar to rounding them. You need to extend the repetend, the repeating digits, just like you would to round them. Because this digit here is still 0.21. But this one, this number is really 0.21, but it continues forever. So it's really 21, 21, 21, etc. Okay? So you need to write out some extra digits in order to compare. Okay? So then you can see the 0 is the same, right? There's nothing in the ones column. Okay, I have a decimal. Then the 2 is the same. Then the 1 is the same. Then the next digit, if I were to extend this decimal 0.21, there would be a 0 there. So which one of these, 0 or 2, is bigger or is smaller? Okay, so in this case, this one is larger. So if it said to use a comparison symbol, then I would do this comparison symbol. This number, 21 hundredths, is less than repeating 21 hundredths. Okay, one last thing for you to do. If you were given a problem where it says find 5/6 of a number, like $12.47, there are 2 ways that you can do this problem. One way, option 1, is to convert the fraction to a decimal first. Okay, so let's divide. 6 goes into 5 how many times? Put a decimal up here. We're going to end up with 8. 48, subtract, we get 23, and then subtract 2, looks like I need another 0, 2, 0. Okay, so see how this repeats? So this would end up being a 3, so 5/6 as a decimal would be decimal point 8 repeating 3. Okay, so, and you know that of means to multiply. Now I can't multiply this repeating 3 with 1247. So you're going to round this number to the hundredths place. So we're actually going to multiply 1247 times decimal point 83. So 7 times 3, 21. You can work this math out on your own and then check your work with mine. 12, 13, 14, 7, 3, leave a 0, 56, 37, 19, 9. Okay. 1, 0, 5, 12, 13, carry the 1, 10, and then count your decimal places. This is a really good example of all sorts of things. Decimal places 4, 1, 2, 3, 4. Okay? Now this is money, right? So I'm not going to leave these extra digits here, so I need to round to to the nearest hundredth, because that is cents. So this is going to be approximately $10.35. Okay, but I told you there were two ways you could do this. Option 2, you can just write this as a multiplication problem. So it's 5, 6 times 1247. So you would multiply times 5 and then divide by 6. Or you could divide by 6 and then multiply times 5. Either way, we're going to multiply times 5 first. 1247 times 5, 23, 12, 62.35. Now we need to divide that by 6. So we're still going to end up with dollars. So $10 and how many cents? 3, 18, 55. Oh, that's 9, right? 54, and then I would end up with a 1. So using this method, again, we're going to round to the nearest hundredth. So using this, we would end up with approximately $10.39. Now, notice these two digits, two values, are not the same. Now, what accounts for that difference? Well, here we took a fraction that is actually equal to 5 out of 6. Up here, we took the decimal approximation. Okay, so we rounded this to this fraction, 5/6, is actually an infinitely long decimal. So we took that infinitely long decimal and rounded it to the hundreds place. We rounded it to 2 digits, when in fact it really goes on and on and on forever. So this answer is more accurate, but this one's close. Okay? So just know that anytime you round decimals, you introduce some error into your calculations. Okay? That's it. So I don't know how much of this problem you'll actually use in the assignments, but if it comes up and you have questions, definitely let me know. So that's it for lesson 30. Hopefully, at this point, you can say, yep, I can do objective 1, 2, and 3. And if you can't, please write down some questions you have and either respond in the notes, response form online, or ask in class. I'll see you then.